getaddressinfo, the POSIX interface to the DNS, will return a list of addresses in a particular order. The order of these addresses is by no means random, and in this video we will take a closer look at that order and why trying addresses in that order is a good idea in general. When everything was IPv4 only, address selection was easy. But the internet currently offers two address families, IPv4 and IPv6, and things are a bit more complicated. But it's not just the fact that there are two address families to choose from, but the IPv6 addressing architecture allows multiple IPv6 addresses to be assigned to a network interface, and addresses have different scopes such as link local or global. Things get even more complicated when a host has multiple network interfaces, so in the end there might be a non-trivial choice between multiple source and destination addresses, and getaddressinfo orders its return values according to the best chance of a successful attempt to reach a given host. So an application is encouraged to either try them in the order they are returned by getaddressinfo, or in parallel, but not to simply try the first one and then give up in case that didn't work. The algorithm that determines the ordering of the results returned by getaddressinfo looks at both the destination addresses, which are the addresses that getaddressinfo was supposed to resolve, and the source addresses, which are addresses assigned to local interfaces, which is an important consideration, because choosing an IPv6 address as a destination, when there are no IPv6 addresses configured locally, for example, will simply not work. So the first step in determining the order of the results of getaddressinfo is figuring out potential source addresses for every possible destination address. In order to stay within a single address family, IPv4 addresses are converted to IPv4 mapped IPv6 addresses. The second step is to find the best source address out of all possible source addresses for a given destination address, so that only a single source address remains. After step 2, we should be left with one or more tuples consisting of a destination address and corresponding source address each. Finally, as a last step, these address pairs are ordered based on the system's preference, which is the ordering getaddressinfo applies. The visible part of this process, however, is only an ordered list of the destination addresses. The question really is, what is the basis for all of these decisions? It is a policy table defined in RFC 6724 and a set of ordered rules. This table is not unlike a routing table because it uses longest preface matching to select candidates from the table. But instead of selecting an outgoing interface as the routing table would do, it orders addresses by preference. Let's have a closer look at that policy table. Without going into all the details, every address range in the table receives a label. Labels are part of the address selection process for both destination addresses and source addresses. Precedence is used in destination address selection, which means getaddressinfo is using that information. The higher the precedence, the further up in the list an address might be. Precedence alone cannot be the sole criteria, however, as appropriate source addresses need to be locally configured too. But looking at the precedence a little closer, one thing becomes clear. The highest precedence is given to the loopback address, which makes sense when you want your communication to stay local. There is no sense in doing anything else with a loopback address. The second highest precedence, however, is any IPv6 address followed by IPv4 addresses. These are expressed here as IPv4 mapped addresses, which are IPv4 addresses written in IPv6 notation. This table therefore says, given that a host can communicate over IPv6, IPv6 is preferred over IPv4. This is important for two reasons. Firstly, this way, hopefully IPv6 will become increasingly used and will replace IPv4 over time, as systems prefer the IPv6 address family. Secondly, as a programmer, you should really make sure that your programs are IPv6 ready, as your system prefers to use it. Another important aspect of this preference is that it can be overridden in case there are important reasons for it. Under Linux, the file gai.conf under etc is where the policy table can be altered to fit one's own need. But for most use cases, the default table should do. The whole address selection process is kind of complicated and contains a lot of details. Basically, source address selection only applies to IPv6 addresses. Routing typically takes care of choosing the outgoing interface. With IPv4 addresses, we should be done at this point, as there's a single IPv4 address assigned to an interface. IPv6, however, is more complex, as it, for example, allows an interface to have multiple IPv6 addresses assigned to it. The question is, which one to use? The decision process is basically a pairwise comparison of candidate addresses until a single preferred address remains. This is all hidden from the programmer, as this is typically all done by the operating system unless the programmer chooses a particular interface and/or address as the source address. Both source address selection and destination address ordering are based on a longish list of rules, which are applied in a predefined order until a result has been established. Without going into too much detail, the rules make sure that by using a particular source address destination address pair, the chance to successfully communicate is maximized. In order to achieve this, the rules make sure that there are actually source addresses configured that can be used with a given address, or that deprecated address ranges are avoided if possible. Also, address pairs where the address scopes are aligned are generally preferred, for example, an address pair where both addresses are of a link local scope are preferred over an address pair where scopes do not match. Also, the previously shown labels from the policy table play a role, and of course, the address precedence value from that same table. There are more rules, but generally these result in sensible defaults with a goal to maximize the chance for successful communication and to prefer IPv6 over IPv4. Let's have a look at how this plays out on a real system. You might remember this example. It's a program we did very recently. It's basically a little tool that takes a single command line argument, which is a DNS name, and resolves using the DNS system this name into one or more IP addresses. Now, it just dumps all the information about these IP addresses onto the terminal. Let's have a look how this actually works on the system. And as you can see here, for this particular name, 2 IP addresses are returned in this order. So first an IPv4 address is returned, and second an IPv6 address is returned. And this order is not coincidental, but it really is meant to be this way. The question is, why on this given system is IPv4 preferred over IPv6 when we learned that, generally speaking, IPv6 is preferred by getaddrinfo? Let's have a look. So these are the locally configured IP addresses. For one, we have an IPv4 address, which has a global scope. Even if it's a private IP address, in IPv4, private IP addresses have global scope because usually they're used in private networks to connect to the global internet, and there's a NAT router in between. And secondly, we have an IPv6 address, but the scope of this address is only link local. So the DNS gives us back a globally reachable IPv4 address and a globally reachable IPv6 address. But we only have a globally reachable IPv4 address locally configured. The IPv6 address is link local, so it's only valid on this given link. Trying IPv6 here first will probably fail, and we have to revert back to IPv4 anyway. So the ordering here, given back by getaddrinfo, makes sure that if we try the first hit or the first result given back by getaddrinfo first, we will probably succeed in establishing a connection, whereas when we try the second one, the likelihood of actually being able to connect over IPv6 here is way less. Let's try a different system. Here on the right side, we have a system where we have a global scope IPv4 address. We also have a link local IPv6 address, But in addition, we have a global scope IPv6 address, so an IPv6 address that we can use on the public internet. Let's see how our program reacts here. We get the same addresses back as we did on the other system, but the order is different now. So the first result that is given back to us by getaddressinfo in this case is the IPv6 address, and only the second choice is the IPv4 address. And the reason is, here we have two global addresses locally configured, so we have as a potential source address a global scope IPv6 address and a global scope IPv4 address for our two destinations, which is a global scope IPv4 address and a global scope IPv6 address. So now the address pairs that we receive, the two global scope IPv6 addresses for source and destination and the two global scope IPv4 addresses for both source and destination, are basically equal in that respect. And now the preference for IPv6 kicks in. So in this case here, we would use, on this machine, we would use IPv6, and only if this fails, we would use IPv4. So one thing is maybe unusual. If we go back to the left system where we only have a link local IPv6 address configured, we still, if we invoke our program, get back both an IPv6 and an IPv4 address. Let's try something. Let's switch off IPv6. Let's have a look at our interface. And as you can see now, the IPv6 address is gone. So we don't even have an IPv6 address locally configured anymore. Let's invoke our program again. Still, we receive an IPv6 address as an answer. It's still our second choice, but it now doesn't really make any sense anymore because there's not even an IPv6 address configured locally. So the question is what to do about this, right? We can't really use it anymore. And when we go back to our small program, the way we configured getaddressinfo was through flags. And there's one flag that tells getaddressinfo to only return addresses that actually have a matching source address on the system. So if we recompile and run the program again, we see that now only the IPv4 address is actually being returned by getaddressinfo, because it will filter all the addresses that are absolutely not usable on the current system. And that's a good thing to remember when using getaddressinfo. It is time again to try this out yourself. Look at how your system behaves and try to reason about your operating system's choice. If you have trouble understanding it, you might want to peek at RFC 6724 and look at the rules that determine that choice.